If search works, but sorting or aggregations look wrong, it is usually a mapping problem. Let's fix text versus keyword and use multi-fields so results behave predictably. You have messy results. You can search fine, but counts and sort order lie to you. I will show why that happens and how to fix your mapping so search, sort, and aggregations all tell the truth. By the end, you will know when to use text, when to use keyword, and how to combine them. I'm Professor Pi, teaching search and IR with simple Python. Many teams discover this problem when a search box returns useful hits, but dashboards and sorts are useless. Success here means consistent behavior, full text search for relevance, exact fields for sorting, and counts. This is a mapping and indexing choice, not a query magic trick. Think of text as something you analyze and break into words for relevance. Think of keyword as the raw string you keep intact for exact comparisons. A simple example is a product title you want to search by words, but also sort by exact name or aggregate by brand. Using both gives you reliable results. We will build a tiny index with 2 example documents, then demonstrate the common failures, add a keyword multi-field, run a proper aggregation, and combine full text matching with an exact filter. This keeps the code compact and focused, so the mapping idea is obvious. This snippet uses the Elasticsearch client to index 2 documents and run a match query. This snippet shows the basic flow. Create an index, push 2 small documents into it, and ask Elasticsearch for matches on a text phrase. The important idea is that indexing tokenizes and analyzes text when the field is typed as text, so the match query looks up tokens rather than raw strings. Key steps you will see are creating the index mapping or relying on defaults, indexing 2 documents so the corpus is non-trivial, and issuing a match query that returns documents ranked by relevance. In practice, this demonstrates that search works when text is analyzed correctly. Now, we will try to sort by that same field and see what breaks. This example attempts to sort on a text field and shows the failure. This example highlights the mismatch. You index the field as analyzed text for good search, but sorting expects an exact value. The snippet illustrates either a rejected request or non-deterministic sorting because the text field is tokenized and stored in a way that does not support simple order operations. You will see the attempt to set a sort on the analyzed field and observe that Elasticsearch does not perform the expected exact sort. The takeaway is clear. Text fields are for relevance, not for exact value operations like sorting or reliable grouping. Next, we will add a keyword multi-field and run a sort with it. This code adds a keyword multi-field in Elasticsearch and sorts with it. This code shows changing the mapping so a single logical field has 2 representations, the analyzed text version for search and a keyword subfield for exact operations. The snippet highlights creating or updating the mapping to include the keyword subfield, reindexing or indexing documents that now carry the subfield, and issuing a search that sorts by the keyword subfield. You will notice sorting now behaves predictably because the keyword subfield preserves the raw string. If you change the keyword behavior, for example by lowercasing at index time, sorting will follow that normalized representation. Next step is to run an aggregation to count unique values. This snippet runs an Elasticsearch terms aggregation on the keyword subfield. This snippet demonstrates that aggregations like terms require exact, untokenized values to bucket documents correctly. The aggregation call targets the keyword representation, so you get meaningful buckets and correct counts for each exact value. The paragraph walks through requesting the terms aggregation on the keyword subfield, watching how terms are grouped, and understanding that using the text field here would produce misleading buckets or errors. The important parameter to note is the field you aggregate on. Choosing the keyword version gives exact counts and stable bucket keys. Finally, we will combine full text relevance with an exact filter for precise results. This snippet combines Elasticsearch text match with an exact keyword filter. This snippet demonstrates a common pattern. Use a match query on the text field to get relevance ranking, and apply a filter on the keyword subfield to restrict results to an exact category or tag. The flow you see is a Boolean query that contains a match clause for relevance and a filter clause for exact equality on the keyword subfield. The benefit is speed and determinism. Filters are cached and do not affect scoring, while the match clause determines ordering. This pattern is the backbone of many product and content searches, where both fuzzy matching and precise constraints are needed. In a real system, this maps to product search, where titles are text, and SKU or brand are keyword. The same pattern scales to larger indices and to dashboards that need accurate counts and stable sorts. Recap. What it is: a mapping choice that gives you both analyzed text for search and raw keyword for exact work. When to use it: use text for relevance and keyword for sorting, filtering, and aggregations. One caveat: adding keyword subfields increases index size and requires thinking about normalization and case. Next step: tune the text analyzer to match your search needs. For example, adding or removing tokenization rules or n-gram behavior, so relevance aligns with user queries. If short, practical IR helps, subscribe and watch the IR videos.